Okay, guys, in this example, we are going to switch from computing integrals of the type that when we integrate over the arc length. Now we're going to integrate just over dx and dy. Okay, so this looks like a regular integration, but it's still a line integral. So we're integrating over some curve, and dx is just a small change in the x direction, and dy is small change in the y direction. Okay, so how do we go ahead and integrate it? Well, we need a parameterization for whatever curve we got. In this particular example, we got a line segment. So we've got point P with coordinates -3, 0, and then point Q with coordinates 5, 3. So I just named them so that we can see what does that vector PQ, which shows direction of that line segment, going to look like. So I will subtract the coordinates of phi from coordinates of q. So we got 5 minus 3, which is 8, and then 3 minus 0, that's 3. Okay, so this is our vector, direction vector. So now we're ready to make a parameterization for the line segment. So remember, we need a point where it starts. So this is going to be -3, 0. We write that. And then the coefficients of t will be the coordinates of the components rather of vector PQ. So this is going to be 8t, and then this is going to be 3t. And because of the parameterization we make of the line segment, it should be from 0 to 1, so that you verify if t equals 0, you will get -3, 0, so point P. And then if t equals 1, you will get 5, 3, which is point Q. So that is a correct parameterization. So let's just go ahead and type that for now. 3t, and t goes from 0 to 1. Okay, so next we need to figure out what is this going to be y squared dx plus x dy. Okay, so we're going to carefully figure this out. First of all, you need to understand that dx and dy does not magically turn into dt. This is changing x, but x has a formula, right? So whenever this dx you see, this is the same thing as finding the derivative of x and multiplying that by dt. If it's dy, that's the same thing as derivative of y multiplying that by dt. Okay, so if we take out dt, it is just going to be y squared x prime plus x y prime. That's what we need to figure out. Okay, so what is our y? Well, that was 3t, so we're substituting that, squaring that. Now, what is x prime? So let me compute that over here. So x prime equals 8 and y prime equals 3. So for x prime, we're going to put 8. And then x, what was x? -3 plus 8t. Multiply that by y prime, which is 3. Okay, so we should be able to simplify this a little bit. So when you square 3t, you get 9t squared. Okay, and then I'm going to distribute that times 3 to the terms and see if I can get rid of the parentheses. So this is going to be -9 plus 24t. So 9 times 8 is 72t squared plus 24t minus 9. So I just simplified it and put it in the descending order of powers. Okay, so let's see if that's correct. Let's check that. Okay, so next we just have to integrate. All right, so how do we integrate? It is very simple. We just integrate whatever we just found. Okay, so this time you're not multiplying by any kind of square root of x prime plus y prime. It's nothing like that because this is not ds. This is dx dy. So we already involved x prime and y prime as part of it. So this is going to be 72t squared plus 24t minus 9. Okay, and then with just regular dt integral. So this is going to be 72 t cubed divided by 3 plus 24 t squared divided by 2 minus 9t. And we substitute 0, 1. Okay, so we can go ahead and just compute that. So it's very easy because we just substitute in 1 because that's 0, it's 0. So I got 27 for that integral. So let's see if that's right.